Hello, students. A very good afternoon. Uh, let's wait for some time, and I'm hoping everyone is joining soon. If you all can hear me loud and clear, just drop a thumbs up. Okay. All right. Fine. I'm getting messages. We have 10 students joined. All right. Okay. Those who have any doubt in between, they can definitely drop messages in the comment section. Okay. So I'm having my chat screen open, and uh, constantly I'm just looking it. Okay. So yeah. All right. Thank you everyone. So let's start. So we'll be continuing with last time's paper, which we did half. I guess more than half, and I'll see if I can finish this one paper as well as the second paper. Okay. So this paper is again continuation of 2018 March. All right. So I'll just quickly go through the revision of whatever we have discussed in last class. All right. So all are there with me? Let's start. Total only 9 have joined till now. So maybe I can wait for 2 minutes and then I'll start. I'll just drop a message in the groups. Okay. So let others join. By the time we'll start with the revision. So last class we discussed 2018 March paper. Okay. So questions were this way. First question was first, second, third, and I think fourth. Total first to four questions are MCQ. First question: when a charged particle enters a magnetic field at an angle of 60 degree with the field direction, it traces dash kind of path. So if you remember, the answer was a helical path. Okay, it's always helical like a spring like this. It moves in this way. This is called helical. It moves forward as well as circular. So forward and circular like a spring. Okay, it's called as helical. Second question. N identical bulbs, each designed to draw a power P from a supply, are joined in series across the same supply. The total power which they draw is dash. Alright. So what is the answer? P by N. How we get it? See, we know that power and resistor. Okay, how they are related? They are in series, right? They're connected in series for the same supply. Series meaning current will be same throughout. Understood? If current will be same, then what about the total power they draw? The total power will be what? P. See, if one resistor is taking, say example, some amount of power, N will take how much? P by N. Alright, see, we never multiply N times P. If you multiply, that means number of resistors into power. Power is increasing, but as we increase the number of resistance, power should come down. It's very common sense. Resistors meaning fan, light, TV, refrigerator, washing machine, etc. They all are like example of resistors. So more you connect, more power is consumed, right? So total power they consume will be what? P by N is equally divided among them. I'm clear? Okay. Next question was third here. A beam of light passing from air into a transparent medium suffers a deviation of 15 degree at the interface when incident at an angle of 60 degree. the speed of light in the medium is dash. All of you, can anyone just type in the comment section what formula we used? Quickly. I'm waiting. Not yet. Please, someone. Anyone? No one says. Try. You have sufficient time. Try. Okay. I have one. Who said this? Okay, Jonathan. So sin I by sin R is equal to what? Is equal to mu, right? Refractive index. Okay. Here, what is given to us? We are having angle of incident is 60. Do we have angle of refraction? We don't. How do you find angle of refraction? Come on. See, it's not a difficult question. Okay, I'll repeat the question again. A beam of light passing from air into a transparent medium suffers a deviation of 15 degree at the interface when incident at an angle of 60 degree. Then the speed of light of the in the medium is dash. Answer is root 6 into 10 to the power 8. Correct. But how? Okay, there are two formulas here. Okay, normally just concept wise. One is given by mu. The refractive index is equal to. We always take speed of light in vacuum, or you can say in air, over in whatever medium you have to find out. That is mu is equal to c by v. Always. Okay, this is one formula. And the second formula we already know. Okay, these two formulas we know. So what I can say about this, basically mu is what? Mu is always taken as n2 over n1. Right? I'm just explaining the concepts. Okay. So let me see where I can write. Okay, I'll erase this. Okay. So now we are having theta is equal to how much? 60 degree. That is my what? Angle of incident. Okay. And angle of deviation is where? Angle of deviation is 15 degree. Okay. This is my angle of theta 2 as angle of deviation. Yes. Just a second. Okay. Oh, wait, hold on. Yeah. I'll write it here. Okay. Let's understand. I hope you are writing with me. Okay. Let's write this way. So I know that sine of I over sine of R is equal to mu. But we don't know what is my sine of R. Okay. Angle of deviation is given by 15. So simple case. If incident angle is this much and angle of deviation is this much, that means if you subtract, that is angle of incident minus angle of deviation, isn't it is equal to R? Angle of incident minus angle of deviation is equal to angle of refraction. That is how much? 45. So we take sine I, that is what? Sine I is how much? Sine I is sine of 60. Sine of 60 over sine of 45 equal to mu. We have to find out the refractive index. The sine of 60 is given by root 3 by 2 and sine of 45 is given by 1 by root 2 is equal to mu. Okay, so this root 2 will go on top. It will become root of 6 over will get 2 equal to mu. All right, till here is fine, all of you. This is okay. And finally, we have to find out the speed of light in the medium. So we take like mu equal to same formula, this one. Okay, this mu equal to C by V. So we take C, that is 3 into 10 to the power 8 over V, we don't know. But what is my mu? Root 6 by 2. So root 6 over 2 equal to 3 into 10 to the power 8 over V. Cross multiply the root 6 into V and then 2 into this. So 3 into 2 is 6, right? 6 into 10 to the power 8. And this root 6 will get divided here, right? And can I write my root 6 as the 6 as root 6 into root 6? Out of root 6, the one root 6 cancel. What remains? 10 to the power 8. And we have root 6. So root 6 into 10 to the power 8. The same simple concept. Okay. Note it down. Please note down the solution. Done? If done, then just tell me. Okay, wait. Let's read some comment section. Oh, okay. There's a lot of lag between the stream and the chat. Yeah, I understand. That's why I'm giving some time, right? That's why I'm waiting for some time so that I can see the replies. I know that. Okay. Noted? Fine. Let's move. All right. Next question. The next question is about this is called transistors. Okay, and we don't have transistors in the syllabus. It's removed this year. So we will not go for this. We will do the next question here. To reduce current in the AC circuit, an inductor coil is preferred to a resistor. Why? To reduce current in an AC circuit, the inductor coil is preferred to a resistor. Why? We have done this before. Just tell me the answer. Someone please type. Quickly, quickly. I'm reading. To reduce current in the AC circuit, an inductor coil is preferred to a resistor. Why? One answer is very simple. Less of power loss, right? And second thing, come on. Still I have not got. Okay, fine. I haven't received any answer. So our answer is, it's the same answer. So we have, when we connect register, there is loss of power, right? And we have discussed this since it's related here. The second question itself was saying the same thing, right? Because they are drawing the power, that means there is a power consumption, there is a power loss when you have a resistor. Whereas if you have any sort of inductor coil, then the power loss is almost equal to zero. There is no power loss. Okay, that's because it induces. So that's why we don't have any sort of power loss, and it is always preferred over resistors. All right, simple. 1 mark. All right, next one, question number 6. And yeah, correct. Another answer. Less of heat produced. Very good. And more of energy efficient. Very good. More energy efficient as well as less of heat in case of inductor coils. Very nice. Okay. Question number 6. One proton is moving with 1 meters per second. So this is the circular current loop. Okay. The velocity selector of a proton is directly proportional to the plane of the current loop at its center O, as shown in the figure. What will be the force acting on the proton at the center of the loop? Now, this question I have discussed so many times before. Answer always goes to zero. Why? Because velocity and the current loop, they are what? Perpendicular to each other. Okay. So the cross product between Q V cross B is equal to zero. Okay, V cross B is equal to zero. Okay, not V cross I. Okay, the V cross B is equal to zero. Hence, we have force also zero. Okay. All right. Let's see the next one. The above figure shows equipotential surfaces in an electric field. At which of the points X, Y, and Z is the magnitude of the electric field the highest, and why? Now, this also I discussed, I suppose, and I think you can see the on the screen also. The answer is mentioned here. Electric field is inversely proportional to the distance, right? So, more the distance, what will happen to electric field? Less will be the electric field. So the y distance is very, very less. If you see the gap of y is very, very less from the charge, right? Or you can say that from the surface. From the surface, the y distance is least. That's why the answer is y. The y will have highest electric field magnitude. Okay, the reason is what? Inversely proportional. Okay, I hope you have written this. Those who are new, they can please note down. Next one, question number 8. Identify the part of the electromagnetic spectrum represented by the following wavelengths and arrange them in descending order of their wavelengths. So, these kind of questions are often asked. In every paper, if you see, there will be one question related to this topic. All right. So, it goes like this. We have like 1, 2, 3, I1, I2, I3. Okay. The first one is produced by bombarding a metal target with high energy electrons. In simple words, it's called as X-ray. Okay. In simple words, it's called as X-ray. Next, I2, produced by klystron and magnetron valves. Basically, it is talking about microwave. Remember some words. All right, remember some words. There's a daily applications. Like it's like this is the application, and how exactly this application is made based on this principle. Okay. Then third, produced by vibrations of atoms and molecules. That is nothing but IR or sometimes microwave, where we'll go for IR. All right. So we have to arrange them in what? Descending order of their wavelength. Now we know that X-ray, gamma rays, they all have very, very high frequency. High frequency meaning the wavelength will be very, very less because frequency and wavelength, they are inversely proportional, right? So X-ray will have very, very shortest wavelength. Okay. So you have to arrange in descending. Descending meaning first the smaller will come. First the bigger will come, then the smaller. So I'll say lambda I1, or I can just say I1. Don't have to write lambda. I'll say I1 is here. Last. Then we have microwave and IR. So how to write? Which one will be greatest? Microwave over IR. Just answer someone. I'm waiting. Let's see. Just answer. Which has the higher wavelength? IR or microwave? Waiting, waiting, waiting. It is. No answers yet. Is going to be IR, right? IR is highest. It's going to be microwave. So we'll have I2 here or I3 here. Then we'll have I2 here. This way. Okay. Highest is microwave will come here, IR will come here, microwave is here. So we'll have like this, this, and this. Okay. Fine. Next. Yeah, here only we have. A metal wire of resistance R and length L is bent to form a circular loop. L and N are the two diametrically opposite points on the loop, like this. One point here, L and N. Okay. Right. Now we have what is the equivalent resistance across the points L and M. Okay, very good question. So if you see, first of all, this L and M, they are dividing this entire circle into two parts, right? Na? Circular object into two parts. So if you see, if you draw the properly, this becomes one resistor, this becomes second resistance, right? So if entire circle is having resistor, how much? How much? R. Agree? So R is the entire. So L takes R by 2 and M takes also R by 2. And how they are related? See, they are parallel, isn't it? This and this will be parallel because their arms are joined parallelly if we check. If they are parallel, then how do we add? We write like 1 by R equivalent equal to 1 by R by 2 plus 1 by R by 2. Because R by 2 is a resistor for each. Agree? So now how to do it? So this two will go on top. It becomes 2 by R plus 2 by R. Notice 2 by R plus 2 by R. R is common denominator. 2 plus 2, 4. So 4 by R. So we'll have 1 by R equivalent is equal to 4 by R. That means R equivalent is equal to reciprocal of this. So R equivalent is equal to R by 4. Note it down. Please note it down. Okay. Let's continue. Next. Question number 11. We are having a graph where, and let me just remove this so that will be easier. A graph of, oh wait, did I miss any question? Oh yes, I missed here. Second question I missed. Check. Even this one I missed. Ninth second. How will the resistance across the LMN change if the temperature of the loop is increased? Answer this. How will the resistance across the points LMN change if the temperature of the loop is increased? Come on, someone. Answer. See, these are the very simple questions. You can even answer in short forms. Doesn't take like long time. Come on, someone. Come on. Please hurry. And those who have done, those who know, they can move with the 10th question. They can just try solving the 10th question again. If you have done still. Come on, guys. How will the resistance across the points L and M change if the temperature of the loop is increased? I don't think so it's difficult. It's kind of like very simple. See, we know the temperature in the resistance, there has to be what? Directly proportional. So if you increase the temperature of the loop, obviously, what will happen to the resistance? It will increase, isn't it? It's very common. And you have done this before. Okay. I'm going to erase this. Okay, let's solve this question. Question 10. I think it's all 2 marks, I believe. A metal rod AB of length 20 cm is kept in contact with the conductor PQRS of a negligible resistance to form a loop as shown in the figure. A magnetic field of 0.2 Tesla is acting perpendicular to the plane of the loop. Okay. The resistance of the rod AB is 2 ohms. Determine the force required to move the rod at a constant speed of 3 meters per second. Okay. We need to find the force. Now, formula for the force is given by force is equal to E by R B V L. This is the formula. Okay. One of the formulas. Where E is called the induced the EMF, B is the magnetic field, V is the velocity, L is the length. And let's see what data is given. We have R, yes. We have B, yes. We have V, yes. We have L, yes. Only thing we don't have is E. And E is also given by the same, that is EVL, VVL. Okay, E is equal to VVL. So we have B, yes. We have V, yes. We have L, yes. So we can easily find out what? E. And this value of V, just put it here. So how do you substitute? B is magnetic field, 0.2 into 3 into B is 3 and L is how much? Length is how much? 20 centimeters. So we have to take into meters, it will be 0.2 meters. So I'm not solving in detail. You can easily do it. Okay. Coming to the next question. Question number 11. A graph of stopping potential against incident frequency for two photosensitive metals A and B is shown. Can you see A metal is here and B metal is here? Which of the two metals A and B has the higher threshold wavelength? Which is having the highest threshold wavelength? What do you feel? Answer please. If possible, write the reason. Otherwise, at least just answer A and B. That much I am expecting. Come on. No reply. No reply. No replies yet. No replies yet. Which of the two metals A and B has the higher threshold wavelength? Metal A or metal B? No reply yet. See, let's understand this way. This is the symbol for frequency, right? Okay. Frequency and wavelength, they are related inversely. And there is something called work function. This is from which chapter? Photoelectric effect, right? Photoelectric effect, right? Dual nature. So work function is what basically? Work function is the minimum amount of energy we need to bring the electron from a photosensitive metal plate, right? That is called work function, represented by phi. So here the energy is normally proportional to frequency. But we are asked what? We are asked threshold wavelength. So how the wavelength will be proportional? Isn't it going to be inversely? Inversely proportional to the energy, that is work function. Okay. And here the frequency of which metal A or B is higher. At least now you can tell me the answer. Still I'm just waiting. Just say A, B something. Metal A or metal B? No. No answer. Please answer someone. Finally someone answered. Metal B. Okay. Now why metal B? Can you tell me the answer? Okay. I'll answer. Let's see. So we know that work function and 1 by lambda, how they are proportional? Inversely proportional. Now look at the values. Okay, we'll check at every single point, even if you take like this point, okay, and this point. For the same stopping potential, check two different values, isn't it? Right? Which is greater? For B, it is every time greater. Right? For B, it is every time greater. What is greater? Threshold frequency. If threshold frequency is every time greater, then what about the threshold wavelength? Has to be minimum. Got you all? If it was threshold frequency, then answer is check. Then the answer is B, but it is threshold wavelength. So metal A will have higher threshold wavelength. Did you understand? Is fine? Understood, guys? Okay, fine. Next one. Write the expression for the maximum velocity of a photoelectron in terms of its cutoff voltage V naught. C is given here. Okay, the entire. We know that maximum kinetic energy is equal to half mv square. Okay, and from Einstein's equation, the energy, or you can say the work function, is given by E into V naught. So we let's equate E into V naught, which is energy, is equal to half mv square, right? And what we have to find in terms of its cutoff voltage V naught, meaning this one. Okay, or you can say expression for the maximum velocity, that is V max. So what we do is let's shift your 2, then you shift your m, and then shift your root. So it will become 2 into EV naught over m and then the root. So this is the answer. Alright. Copy it. Even if you have done, some of you will be new. So just copy it. Done? Okay. 12th question. Okay. The following figure shows the input waveforms A, B, and the output waveform Y of a gate. Identify the gate and draw its logic symbol. Okay. So it's given like you are given input A, input B, and output Y is given. Let's see what kind of logic gate it's forming. So I have discussed this before, but this kind of questions are like very likely, like most likely question to come. And I believe one of this kind of question will be coming in this exam. So don't leave it blank, just understand. Okay. Even if you have done, do it again. Okay, to listen. So we have A and B. We have A, we have A, and we have B. Okay. And we have Y. So when you start from 0, this is going to what? 1. This means 1. This means 1. And this means 0. So we have 1, 1, 0. Okay. Then let's let all the combinations. Then second is going to here 0, 0, 0, and then this is going 1, 0, 0, 1. Next, from here to here is going again 1, 0, and answer is what? 0. 1, 0, answer is 0. And finally we have here, from here to here is 1, 0. This is now 1, and this is the 0, and output is again 0 only. So I think this is enough. Whenever you get all the combination 1, 1, 0, 0, 1, 0, 0, 1, all four combination, you can directly write the answer. Okay, what will be the answer now? This much you type. I think this is very simple. I think it's easy. It's not difficult. Anyone? Okay, you're not answering. So see, normally we have for 1, okay, let's see, 1, 1, 1, 0, 1, 0, okay, then 1, 0, 1, and or let's write in a proper sequence. How do we write in sequence? A proper logic gate is like this: A, B, Y. Tell me which gate is this? 0, 0, 0, okay, 0, 1, 1, 1, 0, 1, and 1, 1 also 1. Which logic is this? Which logic? Okay, I am getting the answer. Very good, very good, very good, very simple. So whenever we have one of the input as high, meaning one of the input as 1, we get the entire output as 1. Isn't it exactly opposite? This is right. Both are 0, then only we are getting 1. Other than that, all we are getting 0, 0, 0. So this is called as OR gate. So this becomes opposite of OR gate, that is NOR gate, not OR. That's called as NOR gate. Okay, good. Okay, very nice. Next one. Okay, this is the, I think, last class most of you found difficult. Okay, let me see if I can explain this again and in a better way. Okay, let's see how we can understand this. So first thing, a point source O is placed at a distance of 12.5 centimeter from a converging lens of focal length 10 centimeter on its principal axis as shown in the figure. Okay, this is the principal axis. Object is here. All right. Now find the distance at which the converging mirror of focal length 20 centimeters should be placed so that a real image is formed on the source itself. Okay. All right. Understood, all of you? So let's see. First of all, what kind of mirror it is? A diverging mirror. So where the image will be coming, image will be obtaining somewhere here. It's given in the question also. Because diverging, right? We trace it back. Diverging, what happens? Converging, we get like, if this is the converging mirror, all the rays get reflected where? On the focus. Here, the image is formed. But in case of diverging, it is not like that. Diverging, it diverts all the rays and then we have to trace it back. It's like, if this is the mirror and this is the block, all the rays will come here, got reflect. Rays will come here, reflect. Rays will come here and reflect in the same path. So if you trace it back, we get somewhere here, right? Virtual. So this is okay. So now see, this is how much given data. Let's see how the data we have. Data we have is 12.5 centimeter from the lens. So from here to here is how much? 12.5. Okay. Now focal length of this particular lens is given to be 10 centimeters. Remember it. Okay. Now there have a length of how much? 20 centimeters. Now to form a real image, let's see what we need to do. First of all, length of distance from here to here. How do you find? We use a simple for mirror, okay, or even two times you have to use. One you have to use mirror formula, and one you have to use the lens formula. Okay. So mirror formula will be given by 1 by f equal to 1 by v minus 1 by this thing. Okay. So find what we have to find, the image distance, right? Image distance. Can we just find out? Use the logic. We are given f. We have our u, and we have to find out. Can you tell me? Anyone? Here on the screen, but I want you to tell me like we're using. Just type. Simple, simple. Last class we had discussed, so I think it should be easy. It should not be difficult. Okay. Anyone try? Let me do it. From the start, I'll do. Okay. Please be with me and listen. It's very simple question. I'll not make flex. So I keep it as simple as possible. Answer is how much? 50 centimeter. Let's see if you're getting 50 centimeter. Okay, let's start. So I think there is a problem. I'm lagging. Someone is messaging. Hello. Hello. Okay. Now you can hear me. There was some glitch, I guess. Just tell me. Is it okay now? Is it okay now? Is it okay now? Just confirm once. Okay, fine. All right. Works. Okay, thank you. Thank you for the information. Okay, let's continue. So let's find out a few things. So what data we are having of lens and of mirror? Okay, we'll start from the left hand side. All right, one by one. The first we have is say lens. Okay, you can take mirror also. But first we'll take the lens because lens is first. Okay, so we need to get some information. So in the lens, what is the formula? Lens thin lens formula 1 by f equal to 1 by v minus 1 by u. Okay. Now, what is the focal length given to us? Is given. And what we need to find out? See, we are having object distance. Do we have the image of the lens? No. So, can we get the image first? So, 1 by v equal to 1 by u is another side becomes what? If you send other side, 1 by f plus 1 by, right? So, answer is how much? 1 by v equal to 1 by f. F is how much? F is given to be 10 centimeter converging lens. And U object is how much? 12.5. But plus or minus, it is other side. It is before the lens. That means we'll have to take this as negative. Okay. Solve it, cross multiply. So it will be 12.5 minus 10 over, you can say 125. How do you all do? Like this, right? Then we have 2.5 over 125, which is equal to, it is coming to be 50 centimeters. Okay. Actually, it will not 50. It is 1 by v equal to 1 by 50. So 1 by 50, if you do, 1 by v is equal to 1 by 50. That means v is equal to 50. Okay. Centimeters. So we got answer as v is equal to 50 centimeters. That is my image of the lens. All right. Okay, so 50. Now, the image has to coincide with the object, right? The image has to coincide with the object, and the light will fall exactly perpendicular. Can you see the diagram? It is falling exactly perpendicular to the surface. And if you can see the arrow means the light which is coming back in the same direction, because the image has to form exactly at the same place, right? Okay, because the image has to form the source. So exactly why the rays are like this. Okay, the question is why the rays are like this, because image is to be formed on the source itself. Wherever we have object, same side we should get the image. Okay, that's why these rays are going backwards. Understood? Okay, I hope this is clear. So, focal length of the mirror is how much? Can I read this part? Just copy this part till here. Copy? Okay, thank you. Now, let's see. The basic formula of radius of curvature of a mirror is given by 2 times f. We don't know what this is. From here to here distance is radius of curvature from here to here. So we don't know what is the radius of curvature. But we do know that what is the focal length of the mirror? 20 centimeters. If 20 is the focal length, then radius of curvature is 40 centimeters. Agree? All of you? So the total distance from here, okay, and where is my image? Image is forming exactly 50 centimeters, right? All of you agree this? That means the 50 centimeters should be equal to the radius of curvature 40 plus the distance between the lens and the scene. It's common sense. Total here to here, image is forming here, right? Image is forming here. That means distance is 50 what we got. And from here to here is how much? 40. That means remaining has to be how much? This is D, right? D. All of you agree what I have written? Am I clear on this? What I have written? So 40 plus D should be equal to total, right? Understood? So 40 from here to here and D from here to here. Okay, so this should be equal, because length is here. Now we count from here. Image, how do we count? If this is a length, then from here to here we count the image length. So image length, I'll just use a different color, maybe red one. From here to here is the image length, which is nothing but addition of 40 plus this D, difference between the lens and the mirror. So 40 plus D is equal to 50. That means D is equal to how much? You can say 10. The distance separated is 10, right? So how much distance? What should be the distance? The diverging mirror should be placed. That is how much? It should be placed exactly 10 centimeter. 10 centimeter away from the lens. Okay, answer is you have to write 10 centimeter away from the lens. Okay, guys. This time it's fine. Understood? Just say yes, no, thumbs up, something. Copy it fast. Okay, let's move. Next one. A screen is placed at a distance of 90 centimeters from an object. Okay. A convex lens forms the image of this object on the screen when placed at two different locations, separated by 30 centimeters as shown in the figure. Alright. Determine the focal length of the lens. Determine the focal length of the lens. So let's see what data we are given. First, write the data. We are given the distance separated is how much? 30 centimeters. And we are given the object distance, right? That is u. How much? 90 centimeters. Alright. But this 90 centimeter is the entire object. 90 centimeter is what? Object plus the image, isn't it? See, 90 is from here to here, from the screen. And on screen, what we get? The image. So distance from object to the screen is total 90. So we will say V plus U or U plus V is equal to 90. All of you understood? And this is 30 centimeter, right? 30 centimeter meaning total from here, see, yeah, from here to here is my V. Okay? Correct, all of you? Screen. And object is from where to where? From here to here. So in simple words, what I'm trying to say is, can I write my 20 centimeter, sorry, not 20, 30 centimeter is equal to the V, the image which is forming, minus the object, right? Making sense? Understood? This distance between the, we can see the distance 30 centimeter has to be what? The difference between the image and the object. Correct? Because addition we are getting 90. So subtraction we will get in between this part, right? This part. Making sense? Alright? Okay, fine. Next. So let's solve this equation together. So one is V plus U equal to 90 and second is V minus U equal to 90. So let's use elimination method. So V plus U equal to 90 and V minus U equal to 30. Use it. Cancel. 2V is equal to 120. That means V is equal to 60 centimeters. So we got V as 60 centimeter. If V is 60 centimeter, then what about U? Okay, V minus 60 is equal to 30. So V, or you can say 60 minus U equal to 30. So minus will go that side and 30 will come this side. So basically we'll get U is equal to how much? 30 centimeter. Okay, fine. I hope this is clear for all. Now the question was to find the focal length. So we have found my U, we have found the V. We have our U, we have our V. So now use the formula. 1 by F equal to 1 by V minus 1 by. So 1 by F equal to 1 over 60 minus 1 over 30. That is how much? 30, it will become something like, no. Object is always taken as negative, so the negative and negative will become positive. Object is always negative, right? Left side. If you see, object is left hand side. Okay? Before the lens. So it is negative. So 1 by 60 plus 1 by 30. What I can take common denominator? I can take LCM as 60. 1 plus 2. So 3 by 60. That is equal to 20. So F is equal to how much? 20 centimeter. Okay? F is how much? 20 centimeter. Just give a thumbs up if you have understood, or if you want me to repeat any step. Done? Just say thumbs up, yes, something. Okay, fine, I'll continue. Next, in a potentiometer experiment, by the way, you have to note it down. I'm going to check, okay? I'm going to check in the class for all of you. Great. So, in a potentiometer experiment, PS is the balancing length obtained for the cell of EMF E1 and internal resistance R1. Alright. How does the balancing length change if the length of the potentiometer wire is double? That is the first question. Let's see one by one only. Okay, the first question. Who can answer? Just one word answer it is. Half, it will be also double, same, something, something. Just tell me. Okay, the answer is, let's see if anyone answered. I doubt. Okay, none of you. Okay. See, the first question. The length of the potentiometer wire is double, then what will happen to the balancing length? It will also double. Okay. Understood? Balancing length will also double because they are directly proportional. This we know from the formula. Right? Like E1 by E2 is equal to L1 by L2. So they are directly proportional. Second, an external resistance R of finite value is connected in series with the potentiometer wire. Then what will happen? So if you connect any sort of external resistance of any finite value, then the balancing length always decrease. Okay, always decrease. Balancing length will just decrease. Correct? Connected in series, right? Okay. This is because the total resistance in the circuit will increase, right? So if the total resistance in the circuit is increased, the current, this increased resistance, the total resistance, which is actually maximum, which will oppose maximum current, and the current is minimized. So what you can say about balancing length? Has to decrease, right? So it will definitely affect the balancing point. Okay, next. And yeah, by the way, if it was connected in parallel, then other way around, the balancing length will increase, because if resistors are connected in parallel, the value drops down. The value of resistance drop down. So there will be increase in the balancing length. Okay, third one. Another identical cell is connected in parallel with E1 with their positive terminals together. All right. So what will happen to the balancing length? In this case now, the balancing length will not change at all. All right. It's because if you add the identical cell in the parallel, does not change the potential difference across the potentiometer wire. So if at all, if you connect in parallel, all right, that is another battery, or you can say cell, then it will never affect the potential difference across the potentiometer wire. Right, the voltage will not change. Am I clear on this? Okay. Okay, guys, note it down in your own words quickly. I'm giving you 1 minute, note it down. Okay. Can I start? Continue? Alright, next. What is the phase difference between the input and the output voltage in a transistor? It's a transistor, so out of syllabus. Ignore. This is also out of syllabus. Ignore. Phase current, collector current. Let's come to the C part. State the type of biasing of the diode shown in the figure above. Here, in the figure, what kind of biasing it is? So we are having, this is positive, this is negative. Okay. The negative is connected to negative 5 volts, and positive is connected to maybe this is a cell or ground. It's a cell, I guess. So it is going to be a forward bias. Okay, because this is negative is connected to the negative terminal and positive is connected to the positive terminal. Now, what is the effect of this type of biasing on the potential barrier height of the diode? The potential in the forward bias, what happens? The potential barrier height decreases, isn't it? And in case of reverse, basically reverse bias, what happens to the potential barrier? It increases. So here we'll have decreases. Okay. Next one. 18th. For a purely inductive AC circuit, show that the current lags the voltage. Okay, this is a simple derivation. Okay, as I said, like we'll have a derivation, all the derivation, important derivation compilation videos. That time we will do it. 18th. 18th O is also a derivation. Very simple though. Okay. 19th is a question. The figure shows two infinitely long and parallel wires P and Q placed 0.2 meters apart perpendicular to each of the to the plane of the paper, carrying equal currents of 20 ampere each. Find the magnetic field at a point R at a distance of 0.2 meters from both of the wires. Okay, very simple. We have P and Q. The cross symbol indicates that the current is current directed inwards. Okay, the current is like inwards. All right. So here also current is coming inside, here also current is coming inside. So let's see R. So at point R, this will contribute and this will contribute. So electric field, magnetic field is given by mu naught I over 2 pi R. And if they are same distance, that means R is same for both. And charge is also same for both. Check. So not charge. Current is also same for both. So both will be contributing the same amount. So I can just multiply by 2 because due to P and due to Q, multiply by 2 is gonna be same because same current and same resist, same distance. Okay. So how do you do? So we multiply 2 here, mu naught by 4 pi, and since we have multiplied, we divide by 2 here. So mu naught by 4 pi becomes 10 to the power minus 7. Then 2 into 2, 4 into what is my current I? I is given by 20 over R is how much? 0.2 meters. So this cancels by 2 times the 20, and we'll have one extra 0. Okay, that will be 100. So 100, 400 will be 2 zeros from here will go cancel. So we'll have 4 into 10 to the power minus 5. Okay, minus 7 plus 2, right? It's going to be minus 5 Tesla. Final answer. Okay. Let's see. Assuming is the again expression Young's modulus. This is very, very important derivation. Okay. When are two sources of light said to be coherent? This is very, very important. Okay. Please, someone can answer. Now, this is very simple. I'm expecting one answer from you all. When are two sources of light said to be coherent? Two sources of light are said to be coherent when their phase difference. What happens when they have basically the phase difference is same throughout, right? Two things. One is what? Phase difference. Phase difference is same, or you can say constant, and the frequency, same frequency. All right. This is two things. And because of these two things, we have something called superposition, one wave onto another. If you have two similar wave, then you know, right? This way, then this adds up and we'll get a big spike, right? Superposition, one wave onto another. All right, guys. Let's see this one. Wait. Someone is. Oh, wait. I'm not checking the live. I didn't check. Yes. I'm checking. What happened? I checked just now. I forgot to check. Okay. Next one. The electron in a hydrogen atom passes from n equal to 4 energy level to n is equal to 1 energy level. What is the maximum number of photons that can be emitted? Now, who can answer this one? Try. Someone. The electron in a hydrogen atom passes from n equal to 4 energy level to n equal to 1 energy level. What is the maximum number of photons that can be emitted? Now, what formula will be using this side? Any idea? Anyone? Okay, let me do it. I'm expecting at least some answers. No one is answering at all. Someone please answer something. See, forget about it's right, wrong. At least you can just give a try, right? Nothing wrong in that. So see, first of all, when any sort of any electron in hydrogen, okay, it passes from n is equal to 4 energy level to n is equal to 2 energy level, the maximum number of photons emitted will be nothing but, let's see how. So we are having first 4 to 3. First, not directly 1, right? First will be jumping from 4 to 3, okay? Then 3 to 2, right? Okay? Then, then 2 to 1, okay? Correct? This is one case. Or it can go from 4 to 2 directly, correct? Right? Or it can go from 3 to 1 directly. Or it can go 4 to 1 directly. All the possible transitions, right? So maximum number of photons that can be emitted will be how many? 1, 2, 3, 4, 5, 6. Each transition, one photon. So how many such possibilities are there? 4 to 3, 3 to 2, 2 to 1, or 4 to 2, and 2 to 1, which already we cannot count second time. Okay, some of you must be wondering, like, if it is 4 to 2, it is not going to 1, because 2 to 1 we have already taken, and then we have 3 to 1, and then 4 to 1. Am I clear on this? All of you understood? Am I clear? This is the maximum, okay? Now, what about the question is twisted in a minimum? What is the minimum number of photon that can be emitted? Anyone? Okay. See, if you see directly, I can jump from 4 to maximum, meaning all the possibilities. Minimum meaning minimum is possible direct jump, that is 4 to 1. So only one photon is possible minimum. Understood, all of you? Let's see the next question. The question is saying the figure shows. Yeah, wait. Someone is asking me. Okay, how? Yeah, you can just type the answers. Like, I'm expecting the final answer, or maybe one word answer. At least try. I'm saying something. That's why I'm giving time. Me just solving and you just listening might not help unless you try something. That's why all of you try to do the next ones if you have done these ones like that. Okay, and I'm giving time so that you can answer the questions if at all, like, you know it. All right, let's go to the next one. So when the maximum number of photon emitted is question is asked, that time we have to see how many jumps. If it was given from, say, example 3 to 1, okay, n is equal to 3 to n is equal to 1, then how many possibilities? 3 to 1 is 1 directly, or 3 to 2 is 1. That's it. Any other possibility? 2 to 1. So 1, 2, 3. In case of if it was n is equal to 3 to n is equal to 1. Okay? Maximum. Okay, minimum here again it will be 1. Next. The figure shows the standing particles on a particle wave on a circular orbit of an electron in a hydrogen atom. Nucleus is here. To which principal quantum number does the given orbit correspond to? To which principal quantum number does the given orbit correspond to? So for that, we'll have to say, let's see how. Let's see how many are there. So first of all, we have like this one. Next, anyone knows? It's a direct question, I guess. This one is direct question. We get like 1, 2, 3, and 4, and here 5. So n is equal to 5. This is the to which principal content number does the given orbit. Okay, yeah, right. N is equal to 5. We have. Yeah, right. N is equal to 5. Okay. And then we have second question is, what is the angular momentum of the electron in this orbit? Angular momentum formula is given by say if you have to find out for a particular, what is the circumference of a circle? 2 pi r. This is the length. Angular momentum is given by what? Angular momentum is given by uh, PLL. Angular momentum is L is equal to P into, or hold on. Okay, I was actually going through the book, and it's difficult to explain you all angular momentum of electron because it's like a figure. So I'll have to explain you using a video how the formation, SD, that the chemistry part, SP, then SPD, then SPDF, I is equal to angular contact number is meaning I is equal to 0, I is equal to 0 and 1, like that. So I need some video diagram for this, especially for the quantization. Okay, this part. Okay, especially for how we get this n is equal to 1. There's some video explanation because the drawing is like, overlapping. It's like a wave from a point, how the waves are coming, how it is forming. So I need to explain with the help of a video. So this I will get the video, then I'll tell you. Right now I don't have. I was trying to get, but I'm not getting. So I'll skip this for now. Question number 21B. Okay, B first and second. Okay, I'll keep this for now. Next. All right. Okay, let's do the next one. How many are remaining? 22, 23, 24, 25. Okay, let's see how many derivations are there. Gray diagram. This is a derivation and a simple question. Derivation. Derive expression by energy stored. Derivation and a simple question. Derivation and simple question. Derivations. These all are repeated derivations. Okay. So you'll see like it's coming out of 3 years paper. One derivation. This one will be 100% repeating. Okay. Then we have again, here. Okay, from here you have to do 22 and 23. So 22 question. A cube of side length L encloses a charged cube. Placed at its center of the center as shown in the figure. What is the flux linked with one face of the cube? Now, see, there can be multiple questions based on this one question. Here is as one face. Sometimes they ask center, sometimes they ask at vertices, sometimes they ask at edge. So you should know what are the things. What are the things like how many vertices are there, how many edges are there, how many you can say faces are there of a cube. All this information you should have. All right. Okay, let's continue. So, and second part, the plane of this square of side 10 centimeter makes an angle of 30 degree with the direction of an electric field whose magnitude is given. All right. Then determine the flux through the square. Okay. So let's start. Step number 1. Let's see how many faces a cube has. Cube has how many? 6 faces. All right. Okay. Okay. So we have the formula, simple formula for the flux linkage, that is phi is equal to Q by epsilon naught. Right. Since we have 6 faces, here the flux will be given by 1 by 6 times Q by epsilon naught. Okay. Just a minute, guys. Yes. So we have flux is equal to 1 by 6 Q by epsilon. 1 by 6 because we have 6 faces. Okay. And second flux from the Gauss law we have E dot ds. ds is the area. Okay. E dot area. Okay. Second flux. Can we equate both of them? Let's equate. So we will get something like 1 by E ds equal to 1 by 6 Q over epsilon naught. Okay. And what other data is given to you? Data is given as side 10 centimeter. Angle is given to you. Okay, fine. Let's do it. So it is given by 1 by phi is going to 1 by 6 EDS is equal to 1 by 6 Q by epsilon naught. All right. So this is our flux linkage. So let's take it. Area of a cube is given by, or you can say one face, right? 6 faces. The one face is like a square, and one side of the square is 10 centimeters. So the area of one entire face will be how much? Side square, that is 10 into 10, 100 meaning 0.10 centimeter, meaning 0.1 meter, right? So 0.1 meter square will be 0.01 meter square. Agree? Okay. And electric field we have, that is given by 4 into 10 to the power 3. And also we have the angle. Angle is how much? 30 degree. Now, this angle is what? 30 degree with what? It's not the same angle. This 30 degree with the direction of the electric field. Okay. So with area vector, how much it is going to be? Area vector is going to be 90 minus 30, which is equal to 60. Remember, whenever you are not given direct area vector, and if you are given the angle with electric field, we have to subtract from 90 minus 30. Alright, that is how much? 60. So final formula is given by phi is equal to EA cos theta. Same one from here on is coming from here. So E is, we are having like 4 into 10 to the power 3 into area is how much? 0.01 and cos of 60. You can easily find it out. So we have two answers, right? First answer was here. This was the part 1 answer. That is for the first part. And second part answer is here. That is for the second part. Am I clear on this? There are two questions. Both the answers I have written here. If you find confusing, then let me know. I'll do it again. I believe like you'll are getting. Alright. Next one. You want to copy? You need time? Okay. I think someone is copying. Just copy. I'll wait. Alright, fine. Let's continue. Last question of the day. A bar magnet of magnetic moment M is allowed to oscillate freely in the external uniform magnetic field of strength B. If the strength of the magnet field is doubled, keeping it uniform, if the strength of the magnetic field is doubled, keeping it uniform, what will be the effect on the time period of oscillations of the magnet and the torque acting on the magnet? Okay, can someone try again? Just a minute. Last question we have. Come on, guys, just try. Okay, let's see. So first step, when the strength of the external magnetic field is doubled while keeping it uniform, the torque, this torque, what we can see is 100% going to increase, right? Because as we increase the strength, it's going to rotate much faster. All right. Okay, and you are keeping it uniform. So remember, in uniform magnetic field, what happens to the dipole moment? The basically magnetic dipole is rotate. Similarly, here also we have, it will start rotating a lot. So it will create a lot of torque. Am I clear? Okay, and also secondly, the explanation you can write it as torque is equal to mb sine theta. So how torque and magnetic field are related? Directly proportional. Okay, understood? And what happens to the time period? The time period of the oscillations of the magnet will be definitely not decrease, because the torque is increasing. So technically, our time period of oscillation has to decrease because going faster and faster. So if you say example, if you go more faster, you covered like more distance in less time. So time will 100% decrease. The strength is increasing. Okay, so oscillations will be happening like a lot faster, and the time taken will be less. Okay, so this is the simple answer. Continuation. An external torque is applied to rotate the bar magnet from a position in which the magnetic dipole moment is parallel to the magnetic field to a position in which it is perpendicular to the field. What will be the change in the potential energy of the magnet? Okay, now potential energy. So it's gonna be a little bit tough. Let's see. Potential energy will be not tough, I'll say, tricky. Yeah, I can say tricky. So what happens to the potential energy is, we know the potential energy, change in potential energy is nothing but final potential energy minus the initial potential energy. Okay. Now, it's very obvious that initial position is minimum, right? Potential energy of the initial position is minimum, is given to us. It's not directly given to us, but we'll have to wait. Let me frame. I just dictate. One of you, two of you, just write it, please. All of you, whoever is present, just write. I'm dictating the answer. See, the change in potential energy is nothing but final minus initial, or you can say initial minus final, whatever, magnitude. I'm talking about magnitude. All right. And as the potential energy at the initial position is minimum and the final position is maximum, so the change will be normally delta U is equal to U final minus U initial. If you see the direction, not direction, I mean the magnitude or direction, let's see. So final is always greater than initial. Okay, in case of potential energy. And if you take final minus initial, we get a positive number, right? Positive meaning we are getting our potential energy as positive. But actually the logic is also like this. If your final energy, final potential energy is increasing, then it's more than the initial, then obviously it is a positive. Energy increases a positive significance, right? Decreasing is negative. So here is potential energy is the final stage will be increasing, so it is a positive. So what will be the change? Change will be a positive change. Okay? It will increase. That's it. Okay, so you can write, it will increase the potential energy of the magnet. Got it? Okay, so with this, I am winding up for now. Next class, I will be discussing the paper, which is 2019. And those who have not understood anything from here, please bring this in the offline class and we will definitely try to solve it. Okay? Again. So, see you all. Bye-bye. All the best. See you all.